the slides. But to give the introduction and to introduce you to the topic, I'll start with a set of slides. So let me begin with a backstory, right? So when I graduated out of college, my first job was with an ERP vendor called the Industrial and Financial Systems. This was a Swedish company based out of in Gothenburg. So I was working for a company. The IFS had an office in Melbourne, Australia, so that's where I used to work. So my first job out of the college was a PL SQL developer back then, and then I soon transitioned to be a DBA. But the kind of work that I used to do, right, like was very similar to this. So how does a ETL workload, the extract, transformation, and load workloads work? Back then, I mean, this was an architecture. This was how the architecture diagram was. So what happens is that between when you have a B2B integration, right? So especially for between ERP vendors, right? Like when you have with an ERP product, when you have a business partner trying to have a transaction between the two. So the typical flow for a ETL workload would be that the business partner would send in a flat file, usually through SFTP in the night. And then what happens is that the typical next step is that pretty much every database vendor out there, they would actually let you read a flat file into the database. So in our case, it was an Oracle database. So Oracle database had something called SQL Loader. So what you do is you read that file using SQL Loader and then write it to a staging table. And then my job was to write a PL SQL procedure to do some kind of a transformation, right? So let's say one business, your business partner had in the flat file the customer information. They might call it as a customer ID, but in our production database, it could be called something like a customer number. So there was some difference, right? So you would do some kind of a transformation. So the PL SQL would handle that. So typically read the file, stage it, and then do some kind of transformation, and then write to the production table. So that was a typical ETL workload that we would do. The thing is, I mean, the problem, as you can imagine, there are with this architecture is that sometimes we would have an issue with the SFTP server, right? The FTP server would go down. Back then, the database was Oracle 8i. So right now, I think the latest version is Oracle 18. So I mean, pretty old. Back then, that's Oracle 8i is when Oracle actually introduced the real application clusters. So it was kind of a buggy also. So that if the database goes down for whatever reason, then we could not, our ETL job would fail. And other issues would be that sometimes we would read the file, and then because of a data error, we would lose whatever we have read, and then we had to repeat this entire process again. I mean, those were some issues we would face. But then back then, the architecture, it was okay. We did not live in a kind of a 24/7, 365 days world, right? So even if a job failed in the night, we would come in the morning and then address that issue, and then it was fine. But then, I mean, today we live in an entirely different world, right? So where your applications they need to be available around the clock, and you need data access to that applications, right? And then DevOps plays a crucial role in transitioning to a data-driven business these days. And more event-driven architectures are on the rise. And so if you look at the ETL that I have shown you, right, so that is still not going away even in today's world, right? Like, I mean, businesses have to communicate, and there are ways, there are businesses that still do the same similar process that I talked about, where they get an ETL file, where they get a flat file, and then they process it, and then they load it into their database. But then, I mean, what the difference now is that the development and operating model around that ETL process has evolved. So those are some examples. And then what I will do during the demo is that I will actually show you some of the machine learning data pipelines, how you can actually create using Spring Cloud Dataflow. So what is Spring Cloud Dataflow? Spring Cloud Dataflow is a toolkit that is used for um, uh, data integration, whether it is data integration or even real-time streaming, and batch data processing that I just showed you an example that I talked about. So an ETL would be a batch data processing pipeline. So Spring Cloud Dataflow, I mean, not only that, it is actually for, the data pipelines that you can create using Spring Cloud Dataflow. It could be that they could be Spring Boot applications. And for event streaming, what you can use, you can use Spring Cloud Stream. And for batch processing, you can use Spring Cloud Task. Out of the box, what we do is with Spring Cloud Dataflow, we provide about 60 streaming and batch applications. And for continuous delivery, we use streaming data pipelines using Spring Cloud Skipper. And finally, for batch data pipelines, you can use something called cron job scheduler. So Spring Cloud Scheduler does that. So for those of you who are not familiar with Spring Cloud Dataflow, I kind of gave in a lot of names here: Spring Cloud Streams, Spring Cloud Task, and so on, Skipper and Scheduler. So once I show you the demo, you will have a fair understanding of what I mean by those. So with that, I'll just go ahead and jump into the demo. So to get started, right, with Spring Cloud Dataflow, the best way to do is, so someone who wants to learn, so go to cloud.spring.io, Spring Cloud Dataflow. So what we do is we provide 3 different platforms where you can actually run Spring Cloud Dataflow. One is local server. This is for a bare metal server. So we provide a jar file, so you pretty much download that. The easiest way for anyone to get started is on the PCF, Pivotal Cloud Foundry server. And also, we do provide Helm charts if you want to do the install on a PKS, on a Kubernetes server. So again, I mean, the thing is, you get a jar file, you do a CF push. So what I have done, the reason I said that it is easy on a PCF is because if I go here, right, so I already pushed my Spring Cloud Dataflow, the jar binary. And then, so the thing is, the services, right? So for Spring Cloud Dataflow to run, for the metadata, you need a MySQL database so that you can actually schedule a stream and a task workflows. And you need a messaging middleware. So we do support Apache Kafka and RabbitMQ. So in this example, for the demo, I have used RabbitMQ. And within Spring Cloud Dataflow, once you have created a data flow, if you want to do analytics, you need some kind of a caching server. So in this case, I am using Redis. But if you are building Spring Boot applications, you want to create a data flow pipeline, you can actually use Total Cloud Cache. Or if you want for very complex workloads, you can actually use Gemfire as your caching solution. So once you have done that, right? So pretty much, I mean, you start the application. So out of the box, when you actually log in, right? So it's empty. So there are no apps, no runtimes, nothing in the streams, nothing in the tasks. So when I said that we provide out of the box 60 different applications, to get that applications, right? Like the way to do that is if you go to this, we provide this Spring Cloud Stream App Starters. So let's say you are building a Spring Boot 2.1 applications. So in this case, what I'm doing, I'm running using RabbitMQ and a Maven. So all I have to do is copy that URL and then go here, pretty much, let's go here and click on Add Application and then bulk import the application. So let's do that bulk import the application. So what it does is, so it was pretty fast, right? So what it does is it actually downloads, so provides you this source, processor, and sink. So what are those 3 different things, right? So when, let's say, source, so source is something, so let's say it could be a file or FTP or a JDBC right? So source is an application that consumes events, whereas a processor is something that you do some kind of a transformation with. So from the source, what you do is, uh, let's say if you picked up a flat file from your source, the processor is what you do process on that, right? And then eventually what you do is you sync it to where do you want to sync it? So you can actually sync it to either a flat file or to a JDBC or any of those. So to demo this, right? So let's do a quick create a new stream. Let's say I'm doing a similar ETL job that I showed you in the beginning. So it could be a flat file. So it's very intuitive. So it's all so you can either do it through Groovy like this, or you could actually use a CLI. But in this case, what I'm trying to do is, so I have a flat file, and I want to do some kind of transformation, and then I want to sync it to a log file. So pretty straightforward, drag and drop. So file, transform, log. This file could be that, like, I could just say, use a directory on my computer, right? So use temp as my directory, and then transform it to, so if I want to do whatever is in that file, I want to convert to it to uppercase, I can do that. And then just put it in a log file. So that's a very simple ETL data pipeline that you can actually create. So once I do that, right, so I can just push it to so let's call this a hello world application, and then create a stream. So what that does is, so if you are running this on PCF, so what happens is that it will, if you go to the runtime, so initially it will say failed, just because that what it does is that job triggers, so that it will go ahead and create application AIs in your case. So it is waiting for those AIs to come up. So the stream is creating application instances for it to start working. So in my case, so as I said, right, like you can actually run this on-prem as well as in the cloud. So if I were to doing this on my computer, right, so what happens is that I'm actually running one version of it on my laptop. So I'm running so the Spring Cloud Dataflow on my server. So what is happening here is that the moment I started, so this is how I started, right? So I'm telling where my MySQL database is running, and the RabbitMQ server is running. Just give the port number, username, and password. So initially, when it starts up, what it does is it will populate the database with all the metadata that it needs. So it will create the tables that it needs, and it will do all of that. It will fill it up, and then it will start the Spring Cloud Dataflow server on your laptop. So in my case, what I've done, I mean, there are different ways, right? You could, so in my case, I'm running Redis, MySQL, and Rabbit as a Docker, the Docker container. But you could just brew install those things on your laptop, and then you could use that. So once I have the Spring Cloud Dataflow installed, let's say in my case, right? So if I have to show you, so streams. So I have already pushed an application. So in this case, Hello World is an application that I pushed. So what I'm trying to do here is that, so if I go to runtime, find my HTTP URL, so 7171. So let's do a post application. So if I do a postman, use postman, right? So to do push a raw message saying that good afternoon, everyone, right? So if I click on send, so I got a 202 accepted. So what this stream is doing is that it is transforming that and putting it into a file. So to see that, right? So if I go to PWD and then do a ls, so if I do more on file sync, so what it did, whatever I typed as a HTTP source, right? So it did the conversion. So it did the transformation, and then as a sync, it wrote to a file. So very simple to do that. So ETL jobs you can easily create using Spring Cloud Dataflow. So that is one use case. Another use case, as I was telling you, is about machine learning. So let's say I want to create a. So I have some examples, right? So for machine learning, Spring Cloud Dataflow. So I have one stream where I am trying to do what I'm trying to do here is that I'm creating a Dataflow pipeline where I can. So if you so here what I'm doing is that I'm saying my directory where I want to put my files is that directory, input directory, and then I'm using image recognition processor. So what this does is it uses the TensorFlow. So TensorFlow machine learning to actually whatever file, whatever image that I put in that file, what it does is it does the recognition. So whether if the image has some kind of an animal, right? So it will figure out what it is, and then either I can sync it to an output file, or here what I'm doing, I'm tapping it into another processor called transform. So in this transform, what I'm saying is that you do so for that image, get me the string and transform that and then put it into a log. So that I can actually identify what's in that image. So what I have done this application, so it takes few seconds for a few minutes to spin up so those containers, right? So if it were to be on PCF, as you can see, if I go back here, right, if I do a refresh, so it will create those containers. If I am running it on a server, what happens is that it will create a JVM. So if I do a PSEF grep on Java, right? So each one of those each one of those stream processes they run as a JVM process on your computer. Okay, so let's go ahead and do a quick demo. So let's see if that machine learning pipeline is working or not. So for that, let's see. So where is it? Labels, metadata, tweets, inception stream, runtime. Okay. I'm trying to see the labels log files. So this is where all my log files are going to be. So let's tail that log file. Okay, clear tail -f that log file. Okay, and let's go find some images, right? So if I want to figure out what kind of a animal this is, if I do save image as, right? So put it in that directory, input directory, save. And then if I look at my log file, okay. So it should actually show up as a giant panda, or if I could select any other animal, right? So for some reason, I hope I'm looking at the right log file. But that is one use case. So one use case is that like the machine learning, right? So that is one use case. Another use case is that like if you want to do some kind of analytics on your in your data pipeline, right? So for that, I have another example called Twitter stream analysis. For that, so let's do this. So let's create a new pipeline. Create stream. So what this is doing is that I have my Twitter feed, that is coming in to this through via Twitter stream. And then I have a filter processor, right? So I'm filtering everything that is coming in, looking for the English language only. And then I'm doing something called Twitter sentiment analysis. This is again, a TensorFlow model that is using the convolutional neural network to actually do some kind of a sentiment classification on my tweets. For this demo to work, right, so you need a developer account with Twitter. So before it used to be easy, but now they made it kind of difficult so that you have to actually tell them what your application is going to do, and then where you're located and all that, then they will approve you. Once you approve, you get this keys and tokens. So that's what I'm doing here. So in this Twitter sentiment analysis, right? So in the Twitter stream, I have actually set up all my access token and access token secret and all of that. So once I have that, right? So I have this log that is that I'm tracing. So to show you that, right? So all my tweets should be going to this log file. If I get the log, and then if I do a tail -f on that. So this is actually coming from my Twitter stream right now. So every tweet that is coming in, it is doing a sentiment analysis, whether if that tweet can be classified as a negative or positive or neutral. So it keeps doing that until I stop it, right? So the data pipeline, I could actually create a new so I can actually analyze that. So the way I can do that is go to this analytics portion. And then here, I created a field value counter, and then I created a counter called sentiment. So all of the tweets that are coming in, they are classified as either positive, negative, or neutral. And positive, I mean, I've been running this for 4 hours now. So the most of the tweets are positive in the Twitter feed that I'm getting. So, I mean, as I said, right, so Spring Cloud Dataflow, it lets you create ETL pipelines. It lets you create this machine learning and data science pipelines. And I actually had, if I go back to my slides, right, so if let's say you want to do some kind of object detection, right, so there is a pipeline that actually does that. So if you can see here, right, so if I put in a picture in my file directory, it will identify that it's a person, it's a kite, and so on and so forth. So those are some examples. So one good example where we use all of our products is this demo from Christian. So in this example, right, so I'm using Greenplum as my my massively parallel database, and then I'm using a PMML. PMML is the machine learning markup language for your whether it is data mining or machine learning. So what this PMML model is doing is that it's evaluating and then using a filter as a transformer to risk all your high risk transactions. You're flagging them, and then using Gemfire as your in-memory data grid. So to demo this, right, so what you have to do is I'm using a point of sale simulator. So let's kick that off so that I can actually show you how it runs. If I go here, so I already started my Greenplum database in Gemfire cluster. And if I submit that point of sale simulator, what happens is that it takes few seconds, and then my machine learning model has already, what it has done is so I already ran some transactions there. So the training has already been done. So this new transactions that are coming in, it will start flagging them. So it takes a few minutes, but what happens is that what it will do, so in United States, right? So it is using quite a few of our products. It's using PostGIS for location-specific data, and it is using Greenplum, Gemfire, and Spring Cloud Dataflow to actually do this. So this will take some time, maybe a couple of minutes. But in the interest of, so as you can see, I mean, it's already started working. So all of the transactions that are coming in. So most of the time, right now, they are all because the machine learning is the model that I have already created. Most of the transactions do not have anything to flag. But if there were to be any issues, the green bubbles out there would show up as red. So pretty cool demo where it shows all of our products. So having said that, now in the next few minutes, what I wanted to show you was some examples, right?